Okay, so in this video, I'm going to talk about finding Taylor series with different power series operations. So we're going to use just power series operations to find these Taylor series. So I really like these examples because I think this shows like some of the creativity that you can use with different power series or Taylor series. So before I get started, I do want to state that knowing these three series is going to be really clutch for this video. If you don't have these memorized, maybe pause the video and write these down. Different math teachers can require different things, but I think these three are like some of the most core Taylor series. So I'm going to build this video around like assuming you've memorized these. And this is the series form of those series. All right, so let's talk about what is this asking for. Okay, so I want to leverage what I know about Taylor series to write out this as a full series. So if I think about what sine of x equals, so sine of x is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial, so on and so forth. So what I'm going to do is I'm going to start then by just expanding this part right here using that. And okay, if you think about this, like we've talked about this also in other like example videos. So this makes sense to do a Taylor series expansion on. I've shown in other example videos that if you were to try to expand these two terms as a Taylor series, you would just end up back at these two terms. You can check out my series on how to build a Maclaurin series or a Taylor series just to see some examples of that. So these terms can just hang out, and we're going to write out what this means for a moment. So let me actually start by writing out those last two terms. And then I will write out the sine of x. So this is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial, so on and so forth. And so now you can see in setting this up that the x's drop out and this x cubed over 3 factorial drops out. So now I am left with really a series that starts at x to the 5th. And so if I wanted to write this in series notation, like how could I do that? Well, I can still just use like this series notation. So this is my series notation. But now, instead of starting at 0, I want to re-index to ensure that I start at, so these two terms canceled out, right? So I want to start at this term. So here is your 0th term, your first term. So this is the second term in that series. So what I'm going to do is I'm just going to re-index this series from 2 to infinity. And then I'm going to use everything else the same. And so that is all I really need to do for that problem. Okay, so let's keep on keeping on. So what do you do with this? Okay, so maybe at first sight when you look at this, you think, oh, sine and cosine. I've totally got a series for both of those. So you could technically multiply these together, but like we know that multiplying two series together, I mean, hopefully you've kind of played around with that a little bit. It kind of sucks to multiply two series together. So we do know things about trig, right? And so this actually is a trig identity. So this actually equals 1/2 sine of 2x. You can like Google like your standard trig properties, and then you can figure out that this is one of the identities. Okay, so I mentioned this, and that like if you can rewrite this, I would much rather do this than have to multiply two Taylor series. So that's what we're gonna do. So from here, now where I have 2x, so I talked about this in another video. So where I have x, now I'm gonna replace it with 2x. So I can just, let's see. I'll just go ahead and set that up. So this will be 1/2 2x minus 2x cubed over 3 factorial plus 2x to the 5th over 5 factorial, so on and so forth. So I can rewrite this then as, let's see, I can put a 1/2 out in front, and all my indexing really just stays the same. So I can rewrite this as -1 to the n, and now this will be 2x to the 2n plus 1 over 2n plus 1 factorial. So that to me is a much easier way to approach this. And if I wanted to make this maybe just a little bit more algebraically compact, what I could do is, so I can mess with this exponent here. So I can rewrite this as, so I'll just show you, this will be 2 to the 2n plus 1, and then this will still be x to the 2n plus 1. But now what I can do is I can cancel out this 2 with this right here. So the most compact way to write out this series would be -1, 2 to the 2n, x to the 2n plus 1 over 2n plus 1 factorial. So there you go. Okay, so that is like a cute, fun little way to kind of game that system. So with that in mind, I've got sine squared x. So again, I know this is sine times sine, but like, once again, do we want to actually multiply two series together? Do I want to multiply sine by itself? No, I would rather not. So I think this could be a good moment for you to pause and just think about like what is a better identity to use to see if you can finish this. So, you know, you could give it a try and then hit play when you're ready. Okay. So the identity that I'm going to use here is that I can rewrite this as 1 minus cosine of 2x over 2. Boom. So what I'm going to do then is I'm going to factor out the 1/2, so this becomes 1 minus cosine of 2x. And then I can use my old pal Maclaurin series, cosine of x, and I'll just replace all the x's with 2x. So this will become 1/2, 1 minus, and then let's see, I'm going to put parentheses around this, 1 minus 2x squared over 2 factorial plus 2x to the 4th over 4 factorial, so on and so forth. Okay, so now I can just see what's kind of going on here. So for one thing, these ones drop out, and then like as I distribute this negative, all of the signs kind of like flip-flop their indexing. So what I'm going to do then is I want to rewrite this so that, let's think this through. So I want to rewrite this so that I re-index my -1, so I can add or subtract 1 here. And then I can replace this with 2x. So let's go ahead and do that. So I'm going to rewrite this as 1/2. Oh, and then I also want to re-index it so that we don't start at 1. I want to start here. So looking at what my series is, so I'm going to re-index the -1, and then this, I don't want it to start at 1 anymore. I want it to start at the next term, so I'm going to just change this 0 to 1. So let's take this. This is n equals 1 to infinity. -1 to the n plus 1. This will be 2x to the 2n over 2n factorial. Okay, so what else can I do to this now? Well, once again, I can play around with the exponents. So this 2x to the 2n, I'm just going to rewrite it as 2 to the 2n and then x to the 2n. And now I can see that this 1/2 here, I can cancel this out. So this will be n equals 1 to infinity, -1 to the n plus 1. We'll call this 2 to the n minus 1. Or let's see, actually, I'm running out of space here. I'll try to write it here. All right, n equals 1 to infinity, -1 to the 2n minus 1, right? So I can cancel out this 2 here by subtracting 1. And then x to the 2n over 2n factorial. Okay, and so there you go. So that's kind of a better way to approach these. So hopefully this kind of makes sense now of like what you're being asked to do. And it's really like if you know these and then you know some of your trig properties, you're going to be good to go. Okay, so I will talk to you guys in the next video. Thanks for watching. Bye-bye.